Okay, dear student, let's see what is there in this question. The surface of the planet absorbs an intensity 400 watt per meter square. Okay, let me point out this is question number 25 directly, because the other questions from 21 to 24, they are not in your syllabus, so I'm not covering them. They have been removed. 25. The surface of the planet absorbs an intensity of 400 and reflects 100. So let's say this is the planet. So some energy is falling on it, and it absorbs the intensity of 400 watt per meter square and reflects the energy of 100 watt per meter square. The surface of the planet is at equilibrium at a constant temperature. The surface of the planet is at equilibrium at a constant temperature, because that is the condition of the equilibrium, that the total heat which is absorbed by Earth will be given out by Earth. Otherwise, the temperature of the Earth will increase. So they've just given you the condition in the second statement. What is the albedo of the planet's surface and the radiated intensity? So of course, the total energy that is coming will be 500 watt per meter square according to this. 400 is absorbed and 100 is reflected. That is clearly given here. That 100 is reflected. Reflection is the albedo. So it's 100 divided by 500. Be very careful. So albedo will be 100 divided by 500, and it becomes 1 by 5, that is 0.2. That is the albedo of the planet. Now that is clear. So albedo is defined as the amount of energy reflected divided by the total amount of energy which is incident on Earth, and that is 500. It is 100 by 500. The answer becomes 0.2. So that is this. Now radiated intensity. Okay, now you want to find what is the radiated intensity. So of course, all the 400 that is absorbed by Earth, it has to go out somehow. So Earth will be radiating this much of energy at some other particular time. Like let's say Earth is absorbing energy in the day and emitting energy in the night. So the surface where the night is there, let's say, at that time it is emitting energy from that part. So we can say that the energy balance is maintained. So of course, the total amount of energy which was absorbed has to be given out. So the radiated amount of energy will be 400. Now, the other option is 300, which is clearly not the case. So there is no doubt that our answer will be B. But there might be another doubt for the students, why the radiated intensity is not taken as 500 instead of 400. So my dear students, listen to this. Like if we talk about radiation, or let's say emission, the emitted energy or radiated energy, these two words, always remember these terms, this keyword, they always belong, they do not include reflection in their calculation. They are concerned with the energy which is emitted by Earth, as if the energy was its own energy. Like we have absorbed the energy some other time, and after a certain period of time, Earth is started emitting the energy. It means like now Earth is emitting this energy as if this energy was Earth's energy from starting. So it is Earth's energy which is emitted. But if I talk about the reflection part here, of course this is not Earth's energy, because it was not absorbed ever. Like the energy is coming and going back. So it's kind of a reflection. So it is sun's energy hitting the surface and going out. So it is still sun's energy. But once the energy is absorbed by Earth, it becomes Earth's energy. So this 400 is Earth's energy. Now this is emitted based on the temperature of Earth. So this is what I want to say. The Stephen formula. What was that formula? Like the power is equal to E sigma AT raised to power 4. This formula I'm telling. So 400 will be used, and the temperature of the Earth's surface will be used. So this energy is radiated by Earth, and that is why the answer will be 4. It will not be 500. Okay, dear students, this is Professor Varun. Thanks for watching. Keep watching other videos. All the best. Bye.